The notion of a self-reproducing computer program can be traced back to initial theories about the operation of complex automata. John von Neumann showed that in theory a program could reproduce itself. This constituted a plausibility result in computability theory. Fred Cohen experimented with computer viruses and confirmed Neumann's postulate and investigated other properties of malware such as detectability and self-obfuscation using rudimentary encryption. His 1987 doctoral dissertation was on the subject of computer viruses. The combination of cryptographic technology as part of the payload of the virus. Exploiting it for attack purposes was initialized and investigated from the mid-1990s. And includes initial ransomware and evasion ideas. Before Internet access became widespread, viruses spread on personal computers by infecting executable programs or boot sectors of floppy disks. By inserting a copy of itself into the machine code instructions in these programs or boot sectors, a virus causes itself to be run whenever the program is run or the disk is booted. Early computer viruses were written for the Apple II and Macintosh, but they became more widespread with the dominance of the IBM PC and MS-DOS system. The first IBM PC virus in the wild was a boot sector virus dubbed C-Brain, created in 1986 by the Farooq Alvi brothers in Pakistan. Malware distributors would trick the user into booting or running from an infected device or medium. For example, a virus could make an infected computer add autorunnable code to any USB stick plugged into it. Anyone who then attached the stick to another computer set to autorun from USB would in turn become infected, and also pass on the infection in the same way. Older email software would automatically open HTML email containing potentially malicious JavaScript code. Users may also execute disguised malicious email attachments. The 2018 Data Breach Investigations report by Verizon, cited by CSO Online, states that emails are the primary method of malware delivery, accounting for 96% of malware delivery around the world. The first worms, network-borne infectious programs, originated not on personal computers, but on multitasking Unix systems. The first well-known worm was the Internet worm of 1988, which infected Sun OS and VAX BSD systems unlike a virus. This worm did not insert itself into other programs instead. It exploited security holes, vulnerabilities, in network server programs and started itself running as a separate process. This same behavior is used by today's worms as well. With the rise of the Microsoft Windows platform in the 1990s, and the flexible macros of its applications, it became possible to write infectious code in the macro language of Microsoft Word and similar programs. These macro viruses infect documents and templates rather than applications, executables, but rely on the fact that macros in a Word document are a form of executable code. Many early infectious programs, including the Morris worm, the first Internet worm, were written as experiments or pranks. Today, malware is used by both black hat hackers and governments to steal personal, financial, or business information. Today, any device that plugs into a USB port, even lights, fans, speakers, toys, or peripherals such as a digital microscope, can be used to spread malware. Devices can be infected during manufacturing or supply if quality control is inadequate.